Pythagorean Theorem, questions 1, part A, B, and C. So the Pythagorean Theorem describes the relationship between the three sides in a right angle triangle. And this only works in triangles that have a right angle or a 90-degree angle in the corner. So the Pythagorean Theorem says if you take the two shorter sides, A and B, and square them and add them together, you should get the same thing as if you took the longest side and squared that. So the longest side actually has a name. It is called the hypotenuse, Hypotenuse, and it is the longest side in a right angle triangle. So if we give this a try, it says solve for the missing side in each of the following. Round final answers to two decimal places where appropriate. So the first thing I check is, does it have a right angle? Which it does. It has a 90-degree angle, which means we are allowed to use the Pythagorean theorem. The second thing I do is I label my sides. So I look for that hypotenuse first. It is the longest side, and it is always located directly across from that right angle. So directly across from that 90-degree angle is our side X, which makes that our hypotenuse, or side C. Now the other two sides, A and B, it doesn't matter which one is which. I think I'm going to call this side B because it's the bottom or the base, and this side A. So our formula says A squared plus B squared equals C squared. I'm going to take the numbers that I know for A, B, and C and sub them in. So I know that A is 6, so 6 squared plus, and then B is 8, so 8 squared equals C, which is X, so X squared. Now 6 squared is 6 times 6, and 6 times 6 is 36. 8 squared is 8 times 8, which is 64, and that equals X squared. So I'm going to add 36 and 64 together. So 36 plus 64 is 100. So 100 equals X squared. So that is the length of the side once you square it. I want to know what is just the length of the side. So to cancel out a square, we do the inverse operation, which is a square root. And the square root of 100 is 10. So that means X is 10 meters. So our missing side is 10 meters. In example B, same thing. First thing I'm going to do is look and see, is this a right angle triangle? And the answer is yes. Then the second thing I'm going to do is try to label A, B, and C. C is always the longest side directly across from that right angle. So this time, the C is 24 meters instead of the unknown. Now A and B, it is your choice which one you want to call which. I'm going to let this side be A and this side be B. So if I write down my formula, A squared plus B squared equals C squared, I'm going to sub X in for A, so X squared, 10 in for B, that's 10 squared, and 24 in for C, so 24 squared. I'm going to square whatever I can, so I'm going to leave the X squared alone. 10 squared, 10 times 10 is 100. And 24 squared, or 24 times 24, is 576. Now, this time, you'll notice there's an equal sign in between those two numbers, whereas last time there was a plus sign in between those two numbers. So in order for us to solve for X, I'm going to start by subtracting 100 from both sides. So X squared equals 576 take away 100 is 476. And then to cancel out that square, I'm going to do the opposite and square root. The square root of 476 is a decimal. So I notice that I have 21.81. So I take a quick peek at the next number. It's a 7. So if that number is a 5, 6, 7, 8, or 9, I'm going to bump that one up. And since it is a 7, that's exactly what I'm going to do. So I'm going to say this is going to be 21.82. So x equals 21.82. That's meters. And since I rounded, I'm going to put a little dot on top of my equal side to say that it is approximately 21.82 meters. Our last example is a little different. We will sometimes see questions like this on the EQAO. So if I take a look, I've got a right angle triangle hiding in the middle of this whole thing. So there's squares on all sides, but the sides of those squares appear to form a right angle triangle right there. So across from the right angle triangle, that's C. And then the other two sides, one of them is A, one of them is B. Now I notice they didn't give me side lengths. They've drawn these squares on either side of the triangle. So I see that they're squares because they've got markings showing that all of the side lengths are the same. So this is the area that you would get if you multiplied the length of the square by the length of the square. The length of the square is C. C times C is C squared. So this actually is C squared. Same thing here. This is a rectangle. Area of a rectangle is length times width. So this would be B times B, or B squared. And then this one up here, right, would be A times A, or A squared. So it doesn't actually ask me to find the side length. It just asks me to find the area of this square. So I'm going to write down the formula. So A squared plus B squared equals C squared. A squared is just X. B squared is 19. And C squared is 42. And then all I have to do is solve for X by subtracting 19 from both sides. So 42 take away 19 is 23. So X is going to be 23 kilometers squared. So this one was a little different. It was kind of weird. We weren't supposed to find the side lengths. You could try to find each side length and then calculate the area, but it was just easier to use the Pythagorean theorem just to find the area of that square. You can check out the next video to figure out how to do the questions on the back.